Okay, so here's a question for you. What if everything you think you're seeing right now, this very moment, is already slightly old news?
It sounds a little bit like science fiction, doesn't it?
It really does.
But that question, it actually cuts right to the core of our sensory experience. And that's really what today's deep dive is all about. We're going to examine this fascinating claim that comes from your sources.
The claim that there's this measurable, persistent gap between what's actually happening in the world and how fast our brains can keep up.
Exactly. So our mission today is to really unpack how the brain manages this fundamental timeline problem.
We're exploring the hard science of consciousness here, specifically the mechanics of how the brain takes in all this information and presents us with what we call the present.
Right.
Because if the sources are right, the timeline we all experience isn't instantaneous. We're constantly playing catch up.
That's the core argument. Our conscious awareness, the moment you actually register something, it operates on a subtle but really critical delay.
Okay, so let's get into it. Forget the philosophy for a second and just jump straight to the data. The sources are incredibly specific about this lag.
They are.
The brain delays our perception of reality by approximately 80 milliseconds.
80 milliseconds.
Yeah.
And it's 0.08 seconds. It feels like nothing, right? The blink of an eye.
Barely, yeah.
But on a neurological scale, where you have signals traveling at these incredible speeds, that time window is it's pretty significant. And it's not a mistake. It's not a bug. It's a feature.
A feature. So why is that time window necessary? I mean, if the world is moving so fast, why can't our brain just keep pace? What is actually happening in those 80 milliseconds?
So the reason for the lag is something called neural processing delay.
Okay.
And, don't think of it like a computer buffering a video. A better analogy is, imagine a historian trying to synchronize reports from completely different departments. You've got sight, sound, touch.
And they're all sending the reports in at different times.
Yeah. At different times and at different speeds. Light hits your retina, sound hits your eardrum, pressure hits your skin. Their signals travel along different paths of different lengths. They arrive in the brain at wildly different times.
So if the brain just showed them to us as they came in, our reality would be a total mess.
A completely dislocated mess of stimuli, yeah.
Okay, so give me an example. If I say, slam my hand on this table,
Right.
the image of your hand hitting the wood might get to your brain a fraction of a second before the sound of the clap does.
Precisely. And to avoid that temporal confusion, the brain just doesn't output anything. It waits. It collects enough data from all the major senses, it reconciles them, and then it integrates them into a single, cohesive, present moment.
So it's waiting for everyone to agree before it shows us the final picture.
It's waiting for a consensus.
Yeah.
And that necessary waiting period, that processing and integration time, that's what adds up to the 80 millisecond delay. It's the price we pay for a stable, synchronized reality.
That makes perfect sense structurally, but this is where the implication starts to feel a little dizzying. If we accept this 80 millisecond delay, then by definition, everything you are seeing and hearing right now, it's not the live feed, it's a replay.
It's an edited version of a truth that has already happened. That's the really profound and kind of unsettling realization here.
We're not experiencing reality directly.
Not instantaneously, no. We are always perceiving a reality that has already passed through the brain's editing suite. The moment a photon from that lamp hits your eye, by the time you consciously register it, that moment is already in the past.
One of the sources had this fantastic phrase for it. It said, we're living just a hair's breadth behind the actual moment.
I love that phrasing because it's such a subtle shift, but it's everything. It's the difference between being truly in the moment and, perpetually chasing it.
Right.
And this raises huge questions. I mean, think about a professional athlete, a baseball batter. The pitch is coming at 100 miles an hour. Their decision to swing is based on visual information that is 80 milliseconds old. If they waited for their conscious process view of the ball's location, they'd be too late every single time.
So that's the practical problem with this delay. And you said earlier, the world is just faster than our neurology can handle?
It is.
But we drive cars at high speed, we catch things that fall, we don't feel slow, we don't feel like we're living with this constant lag, so why not?
And this is where the brain performs its greatest magic trick.
Okay.
Because if we just accepted that 80 millisecond lag, everything we do would feel sluggish, clumsy. The brain can't get rid of the processing time, so it develops this incredible compensation strategy to hide the delay from us completely.
The neurological sleight of hand, I love this part. So what is the solution?
The brain basically covers for the lag by using these incredibly sophisticated predictive models. The mechanism is, think of it as rapid expectations or predictions. Yeah. So instead of waiting for the full 80 milliseconds to pass and then showing you what happened, the brain takes the first little bit of data, the first 10, 20 milliseconds, and it runs these rapid unconscious calculations on what is most likely to happen next.
So it's not just passively receiving information, it's actively trying to guess the immediate future to make the immediate past feel like the present.
Precisely. It's a high-speed simulation. The brain is constantly building a plausible story of what's about to happen based on everything it's ever learned.
Yeah.
When you see a ball flying toward you, it doesn't wait 80 milliseconds to tell you its location.
It calculates the trajectory.
It processes the initial vector and velocity and then predicts where it will be now. And it presents that prediction to you as your conscious reality.
Which means we don't see what is, we see what our brain predicts should be right now, based on slightly old information.
That's the paradox.
Yeah.
The brain is sacrificing absolute objective accuracy for speed and for a seamless experience.
And this whole anticipatory system is what makes us feel perfectly in sync with the world.
It is. We feel like we're right there in the moment because our brain is so good at running this simulation of the immediate future and passing it off as the present.
Yeah.
It's basically lying to us for our own good.
Let's use a concrete example, the classic thing of a glass falling off a counter and you reach out to catch it.
Perfect example.
That entire sequence, seeing it fall, calculating where it's going, telling your arm to move, that has to happen faster than 80 milliseconds or it's over.
It has to. Or the glass is on the floor. And the brain uses these predictive models all the time, even for really mundane stuff. When you step off a curve, your brain isn't processing 80 milliseconds behind you. It has already predicted the impact point of your foot on the pavement. If it didn't, you'd be tripping all the time.
So the goal of this prediction isn't just to make the world feel smooth. It's about survival.
It's an evolutionary necessity. An animal that has to wait 80 milliseconds to react to a predator, well, that animal becomes lunch. So the function of consciousness in this model isn't to give you an objective report of the moment. It's to optimize your response to the moment that just happened.
So reality moves faster than our neurology, and the brain is, as the source said, running after it without us feeling it.
By taking these really, really good educated guesses.
This also kind of explains things like optical illusions, right?
Yeah.
Or when you get motion sickness. Are there just moments where the predictive model fails?
Exactly. When the input is too chaotic, or the gaps between senses are too wide for the brain to bridge them successfully, the illusion shatters.
Like seeing lightning and then hearing the thunder much later.
Yep, the delay is just too long. The brain can't merge those two signals. But for most events, the 80 millisecond prediction machine is so successful that our entire conscious life is lived under this illusion of happening right now.
We're constantly living inside a projection. A curated, edited, accelerated version of the truth.
Designed for one thing, effective action.
Which brings us to the big conclusion from the sources.
The ultimate summary fact is that because of this necessary processing delay, and because the brain has to rely so heavily on prediction to fill that gap, we are, in a very real sense, constantly living in the past.
It's not just a poetic idea, it's a neurological reality. Our perception is always trailing behind the event itself.
Always. The pace of the outside world simply exceeds our internal capacity, and what we experience as now is just the brain's best, most efficient guess at what must be happening.
And this process, this loop, it never stops.
It's relentless. We never get to step outside of it and see the objective 0 millisecond present. It's already been predicted and packaged for us before we're even aware of it.
The brain is the ultimate editor, just creating this illusion of continuity so we can function.
And remember, the whole system is designed for utility, not for philosophical truth. The brain's job is to help you act effectively, not to give you a real-time feed of the universe.
So as we wrap up this deep dive, I want to leave you with one last thing to think about based on all this. If our brain has to rely on these predictions, these guesses constructed from a moment ago, just to keep us in sync with the world, how much of what you perceive as the present is actually just a highly successful, biologically optimized fiction?
Think about your next immediate action. Blinking, reaching for your coffee, reacting to a noise. That moment you perceive as happening now. It's a predicted moment. It's slightly delayed, but it's presented to you perfectly, as if it were synchronized. The present is just the place where your brain's prediction successfully meets reality.
Thank you for sharing your source material for this fascinating deep dive into that 80 millisecond gap between reality and, well, us.
Until the next deep dive.